Hello. In the last video, we learned how to complete the square for simple expressions like this. Let's talk about two reasons why it's useful. This is not an equation because it's not equal to anything. This is just an expression. But if I set it equal to 0, now we could ask, what values of x satisfy the equation? What makes it true? What are the solutions? So I could try and factor. It doesn't factor nicely. I could use the quadratic equation. Or a better option would be complete the square. So when I complete the square on this, I get this side. Here, I've got a nice way to solve it. I know that x is contained inside this squared term, so let's isolate and then undo the squared. I'll add 8 to both sides. Now I can take the square root of both sides. And now I can subtract 1. And that's the same answer that you would have gotten if you'd used the quadratic formula, only you didn't have to memorize a big formula. You can just complete the square and then solve. Okay, let me show you a different reason why it's helpful to complete the square. If you know it or not, this is the equation for a circle whose radius is 3. But the circle is centered at the origin. What happens if I was going to shift the circle right by 2, for example? Here's what the equation would look like. And hopefully this feels intuitive because we're just using the same type of transformation that we've used for other equations. We've replaced x with x minus 2. Okay, so what if I give you an equation that looks like this? You can tell that maybe it's going to be a circle because our equation for a circle has an x squared and a y squared, and this one has an x squared and a y squared. But the problem is it also has this 2x here. So if you have an equation that has two terms with x's, you might think it would be great to be able to combine those into a single term. And so that's what you can do. We could complete the square just on this much of the equation. So we'll ignore this part on the right over here for the moment, and we'll just imagine completing the square on x squared plus 2x. So I know it's going to be x plus something squared, and then minus something. So half of 2 is 1, so x plus 1 squared. When I multiply this out, I'm going to get an extra 1, so I'll subtract that extra 1 here. Okay, so now that I've combined those two terms here, let's regroup everything together. So I'll keep the x plus 1 squared. I'll add 1 to both sides, giving me x plus 1 squared plus y squared equals 11. And now we know that this is a circle with a radius of square root of 11. That part's not important. But what is important is it's a circle that's centered at -1, 0. So we've shifted the circle left by 1. So that's another reason completing the square is useful. If you have an equation where you have the x's separated into separate terms like this, you can complete the square in order to combine them, and that can tell you the location of the center of your shape.